Last week, when we were graphing factored form of a vertex, we sketched a generic graph because we didn't find the vertex, so our graph wasn't quite specific enough. So this week, we're going to take a look at how to find the vertex of a parabola or a quadratic function in factored form. The vertex, remember, is the turning point of the parabola, so it's kind of the most important point of the parabola when you're graphing. And we are going to give our vertex as an ordered pair. We need an x-coordinate as well as a y-coordinate. We also briefly talked about the axis of symmetry. It's kind of an imaginary line right down the middle of a parabola, and it divides it into two equal pieces or two equal halves. The equation for the axis of symmetry, remember, vertical lines have an x equals equation. And the equation will be x equals the x-coordinate of the vertex. So we'll take a look at that as well. Alright, so we're starting with a function in factored form. So the process for finding the vertex is we first have to find the zeros of the function. So remember, to find the zeros, we set y equal to 0. And then we use our zero product property to find the two values of x that would make our equation 0. So our first equation, adding 3 to both sides, and our second equation, subtracting 1 from both sides. So those are our two zeros. Once we have those, we average the zeros or find the middle of the two zeros. Remember, a parabola is symmetric, so your vertex will be halfway between your two zeros. So I'm going to say x equals, because it's the x-coordinate of our vertex, take your two zeros, add them together, and divide by 2. That's averaging your x values. 3 plus negative 1 is 2. 2 divided by 2 is 1. So that's the x-coordinate of our vertex. To get the y-coordinate, we take that value and substitute it back into the original function. So we've got y equals, substituting 1 for x, both places where we see the x, and then we're going to solve for y. So we've got 1 minus 3 is negative 2. 1 plus 1 is 2. So when we multiply those together, we get a y value of negative 4. Once we have those, we're going to write our vertex as an ordered pair. So the x-coordinate we got in green, the y-coordinate we got in blue, that is our vertex. And the last piece, axis of symmetry, very simple. Once you have the vertex, you take the x-coordinate of the vertex and write an x equals equation. So the x-coordinate of our vertex was 1, so x equals 1 is our axis of symmetry. Alright, that's all we're doing in this video, so let's just see it a couple more times with some little bit more challenging functions. Step 1, find your zeros. So we're going to replace y with 0. The 2 can't equal 0, so we don't even worry about that. Set x plus 4 equal to 0, and x plus 6 equal to 0. First equation, subtract 4 from both sides. Second equation, subtract 6 from both sides. Once we have our zeros, we will average them or find the middle, the x-coordinate of our vertex. So we'll take negative 4 plus negative 6 divided by 2. Negative 4 plus negative 6 is negative 10. Negative 10 divided by 2 is negative 5. To get the y-coordinate of our vertex, we take that value, substitute it back into the original equation. Don't lose that coefficient. We don't need it when we find the zeros, but we do when we're finding our y value. Replace x with negative 5 in both places, and solve for y. So we've got 2, negative 5 plus 4 is negative 1. Negative 5 plus 6 is positive 1. 2 times negative 1 is negative 2 times 1 is negative 2. So the coordinate for our vertex is, we got -5 for x, -2 for y. And then finally, to get the axis of symmetry, we just write an x equals equation with the x coordinate of our vertex. All right, same process. Find your zeros. So let's do the shortcut on this one. Looking at the first set of parentheses, if we added 5 to both sides. Second set of parentheses, if we added 7, those are our two zeros. Average them, find the middle for the x value of our vertex. 5 plus 7 are our two zeros. 5 plus 7 is 12. Divided by 2 is 6. To get the y coordinate, substitute that value back into the equation. Don't lose that negative that's on the outside of the parentheses. Substitute 6 for x both places. 6 minus 5 is 1. 6 minus 7 is -1. Negative times 1 is -1, times -1 is +1. So for the x coordinate of our vertex, we got 6. Y coordinate is 1. And finally, that axis of symmetry, writing an x equals equation with the x coordinate of our vertex. One last example, we've got to see one with a fraction. So first we find our zeros. Using the same shortcut, we get -2 and +8. If we were going to subtract 2 for the first set of parentheses and add 8 for the second set, average our zeros. -2 plus 8 all over 2. -2 plus 8 is 6. Divided by 2 is 3. To get the y coordinate of our vertex, we substitute that back into the equation. So we have the 1/2, replacing every x with a 3. Multiplying, well actually adding first. 3 plus 2 gives us 5. 3 minus 8 gives us -5. So I, in this case, would do the 5 times the -5 before I multiply by the half. 5 times -5 is -25. So we have half of 25 is -12.5, or -12.5 if you like decimals. So the vertex then, our x value, we got 3. Y value, we got -12.5. And our axis of symmetry is x equals 3, the x coordinate of our vertex. And here are your two U-try problems for class.